So, let's talk about maybe the biggest question there is, a mystery that's 4 billion years old. Where did we come from? Not just us, but all of this, all of life. How did it begin?
Right. Let's just jump straight into it. For as long as we've been looking up at the stars, we've wondered, how did that very first spark of life ignite on what was once just a barren rock? You could say it's the ultimate cold case. To really wrap our heads around this, we have to understand the timeline. The Earth itself formed around 4.5 billion years ago. But for a very, very long time, it was empty. It took almost 1 billion years for the first hints of life to show up. That's an incredible amount of time for the planet to get its act together.
Okay, so here's our game plan for this little investigation. We'll start by defining the question, then we'll look at some of the wild early theories, from myths to meteorites. After that, we'll see how science put those ideas to the test, and finally, we'll get into the modern recipe for life, from basic chemistry all the way to the first living cells.
First things first, before we can even start looking for the origin of life, we have to agree on what life even is. And, just as importantly, we need to understand what the crime scene, our primitive planet, was actually like back then.
So what is it we're actually looking for? Well, at its most basic level, life is this amazing ability to grow, to make copies of yourself, and to power all of that by using stuff from your environment. That's the target. That's the phenomenon we're trying to trace all the way back to square one.
Seriously, you have to picture a totally different world. The early Earth's atmosphere had pretty much no oxygen. Instead, it was this chaotic soup of raw materials, getting zapped constantly by lightning, cooked by volcanoes, and blasted with radiation. It was basically the perfect, if violent, chemistry lab on a planetary scale. Okay, with that stage set, let's look at how people first tried to solve this mystery. For most of history, without modern science, we came up with some pretty creative explanations for where all this life came from.
For a long time, a really common idea was the theory of special creation. The belief is that some divine power created everything, every plant, every animal, all at once, and exactly as they are today. Of course, that's a world away from the scientific view, which, looking at the fossil record, shows us that different creatures popped up at different times and have been changing and evolving ever since.
And here's the fundamental problem with all of those early ideas. They were based on faith, or what people thought they saw, or just pure guesswork. They were all missing the one thing science absolutely demands: hard, testable evidence. And this is where the story takes a huge turn. This is where science starts to systematically pick apart one of the most popular of these old ideas, the theory of spontaneous generation.
I mean, this was the big question. You leave a piece of meat out, and a few days later, maggots. It really looked like life could just, poof, appear out of nowhere. It seems kind of logical from a certain point of view, but was it actually true? So, back in the 1600s, a guy named Francesco Redi designed this brilliant simple experiment. Jar 1, open to the air, gets maggots. Jar 3, sealed tight, gets nothing. But the clever one was Jar 2, covered with gauze. The flies couldn't get to the meat, so no maggots on the meat. It proved the maggots weren't coming from the meat, they were coming from pre-existing life, the flies.
Redi's conclusion was a huge blow to spontaneous generation. But old ideas die hard. People started saying, okay, maybe it's not true for flies, but what about for tiny things, for microorganisms? The debate wasn't over yet. And this is where Louis Pasteur comes in and just ends the debate for good. His stroke of genius was this S-shaped neck on his flask. Air could get in, sure, but any dust or microbes floating in the air got trapped in the curve. So the broth stayed perfectly clear. The second he broke that neck and let the dust fall in, boom, it was full of life. Case closed. Even tiny microbes come from other tiny microbes. So, wait a minute. If life can only come from other life, how did the very first life get started? This feels like a paradox, right? Well, this is where the modern chemical theory comes in. It suggests life did come from non-life, but not in a single spontaneous moment. It was a slow, step-by-step process, under conditions that just don't exist on Earth anymore. This is called the Oparin-Haldane hypothesis, and the core idea is that the unique oxygen-free kitchen of the early Earth was the key. It allowed simple, non-living molecules to react with each other over millions of years, slowly building up into more and more complex things, the actual building blocks of life.
Now, that was a brilliant idea, but it was just an idea until 1953. Two scientists, Stanley Miller and Miller-Urey, decided to actually try it. They built this contraption to mimic the early Earth. They put in all the gases they thought were there, added some water for an ocean, and then zapped the whole thing with sparks to simulate lightning.
And the result was an absolute bombshell. After just a week, they looked at the water and found it was teeming with amino acids. These are literally the building blocks of proteins, which are essential for everything life does. They had made the fundamental ingredients for life from scratch in a flask.
Okay, so the Miller-Urey experiment was huge. It proved step 1 was possible. But you've got the ingredients. You don't have the cake. How do you get from a soup of chemicals to an actual living cell? Well, let's look at the proposed roadmap.
Scientists think it happened in roughly 4 steps. First, you have your simple inorganic molecules. Step 2, as Miller and Urey showed, these form monomers, things like amino acids. Then, step 3, those monomers start linking together into long chains called polymers, like proteins. And finally, the crucial 4th step, these big molecules start clumping together into little self-contained bubbles, the first precursors to actual cells.
This whole incredible journey, this slow, patient process of chemical evolution, playing out over hundreds of millions of years, finally led to the first true cells, sometime around 2 billion years ago.
Which of course brings us to a final, really interesting question. If it happened once, why isn't it still happening? Why don't we see brand new life forms bubbling up out of volcanic vents or muddy ponds today?
And the answer is just fascinatingly ironic. It's because of the very thing we need to live: oxygen. Our atmosphere is full of it now, and oxygen is super reactive. If those delicate early life molecules would have formed today, the oxygen in the air would just destroy them almost instantly. The conditions on Earth are completely wrong for it now.
And that's really the big takeaway here. The origin of life wasn't just a lightning strike in a pond. It was a long, slow planetary process that could only happen under a very specific set of conditions in a unique moment in our planet's history. It was a window of opportunity that opened, and then it closed, probably forever. It just makes you wonder, how many other worlds out there might have had that same window open, even just for a little while?